The main objective of the Life AgriSed project is to demonstrate the suitability of dredged sediments, used with no intervention or co-composted with green waste, for the production of innovative technosols for the reclamation of degraded soils and of environmentally sustainable growing media for the cultivation of nursery plants. The project stems from the desire to provide a possible solution to 4 very important environmental issues, also with a view to circular economy. Around 200 million cubic meters of sediments are dredged every year in Europe alone, and roughly 60% of this amount is polluted. Only 5% of sediments are reintroduced into the production cycle, while the remaining part is disposed of as waste, with significant social and economic costs. In Europe, around 30 million tons of green residues are produced annually from agricultural sources. It is estimated that only 10–20% of this waste is properly treated and recovered. Peat accounts for about 80% of the total volume of growing media used in Europe. Peat extraction and transport generates high greenhouse gas emissions and the destruction of peatlands and their valuable biodiversity. Soil is a non-renewable natural resource that carries out important ecological, social, and economic functions. Human activity is the main cause of soil degradation. Restoring its fertility and productivity currently requires much time and considerable costs.
The aim of the project is to obtain, through the co-composting of river sediments and green waste, new materials that can be reused as growing media in ornamental nurseries as an alternative to peat, and also new materials to obtain technosols for the recovery and rehabilitation of degraded or polluted soils. We embarked on a long journey to achieve our goal. We started by studying the regulatory framework to understand if our technologies could actually be applied. Then, these technologies were validated through composting and cultivation trials. After we obtained the results, we carried out both technical dissemination involving technicians and scientists, and promotional dissemination involving students and ordinary citizens. Then we moved on to divulging our technologies and philosophy to political stakeholders, to try and make our circular economy technologies more applicable in everyday life.
The national and European regulatory framework has a very assorted and non-uniform structure, with significant differences from one country to another. In Italy, for example, a specific authorization is required for the treatment of sediments.
The study of the regulatory context clearly revealed one of the main critical issues of the project: the need for an authorization to compost these materials. We requested and obtained this authorization from the Tuscany region, but the process was very long and complicated. During the project, we decided to start a lobbying action with the public authorities to raise awareness in political stakeholders of the need to develop quicker and more streamlined organizational processes.
In compliance with regulations, the 2 co-composting trials were then started, one in Italy and one in the Czech Republic.
Effettuare 2 prove di co-compostaggio ci ha consentito di valutare.
The 2 co-composting trials allowed us to assess the effectiveness of the process in 2 different contexts, both in terms of input used. Different sediments and green waste were used in the 2 trials since acquired locally, and different environmental and climate conditions. For both trials, 3 heaps were set up with different volume ratios of sediments and green waste. In the Czech Republic, the heaps were set up on composting platforms, while in Italy, 3 steel composters were mounted with appropriate waterproofing. The composting process was monitored for about 6 months. Continuous remote measurements were taken and analyses were carried out on samples taken periodically from the composts. Despite the different features of the base material and the different climate and environmental conditions, the process was very similar in both countries, leading to complete maturation and stabilization of the material. We can conclude, therefore, that composting proved to be a viable alternative for the reuse of sediments and green waste in a circular economy. Furthermore, the co-composting process also showed that it could be an effective bioremediation technology since a clear reduction in organic contamination was observed in the sediments.
The co-compost obtained was therefore employed as an ingredient for the production of growing media for use in nurseries.
Il progetto originale prevedeva la costituzione di
The original project involved the development of 3 co-composts using green waste and dredged sediments with different percentages, 1:3, 1:1, 3:1 ratio. This allowed us to fully replace peat and other inert materials used in the Pistoia nursery area. But we did not stop here. We went even further and obtained other mixtures, other growing media. Regarding the Czech Republic trials, we mixed our co-compost with peat and pumice. While as regards the growing media for the trials in Italy, we mixed our co-compost with coconut, especially coconut pith and coconut fiber. For all the growing media obtained, we then decided to include a slow-release fertilizer, in particular Basacote 12 months, in the amount of 4 kilograms per cubic meter.
The mixtures we obtained were used as growing media for the 3-pot cultivation trials, in order to validate their performance and demonstrate their validity as alternatives to peat.
La sperimentazione legata al processo.
The experimentation carried out to check the condition and behavior of the growing media during the project involved the use of 2 varieties of 2 very important species, Photinia and Viburnum, that we repotted in 24 cm pots using alternative growing media. Repotting was performed at 2 different points in time. We started in October 2020, both in Italy and in the Czech Republic, with the exact same pattern. We wanted to check how the plants would behave in 2 different areas. And a 3rd repotting was carried out in March 2021. Very briefly, the results show us that the use of these components in the growing media is feasible. The results were actually even better than we expected. We knew that these waste components would clearly not perform as well as started growing media made from extracted material, peat and pumice in particular. Instead, the results were very satisfactory. The plants grew and developed, in some cases growth was slightly lower, but never more than roughly 10%, and the appearance of the plants was always quite comparable with the control plants. This ultimately tells us that the road before us is open and still of great interest.
Piuttosto comparabile con le piante di controllo, il che in ultima analisi ci dice che la strada è aperta ed è comunque interessante.
Using MCM Ecosistemi's patented technology, the sedimentases and the obtained compost were used together with other matrices to reconstitute soils that can be used in the rehabilitation of degraded soils.
Questi substrati sono stati composti da una matrice primaria
These growing media were composed of a primary matrix consisting of dredged eco-compost sediments and secondary matrices consisting of paper mill waste and degraded soils. All these matrices were analyzed using a dedicated software and portioned. Then they were transferred to a pilot plant that reconstituted several technosols. These technosols were initially analyzed through column testing. 18 columns were filled with these technosols and subject to monthly wetting. Data on the chemical physical feature of these technosols were obtained from sensors positioned inside the columns, which collected data every 15 minutes. Furthermore, the leachate water and the pore water in each column were analyzed every 2 months. The analysis carried out at the end of this 8 months of testing showed an improvement in all the features of the technosols in the columns, especially as regards water retention and all soil fertility characteristics. A second test was conducted on these technosols using them as growing media for 2 ornamental species, Viburnum and Photinia. For each species, 140 plants were cultivated, repotted in the autumn, and cultivated for 1 year.
All these purely technical actions were accompanied by other activities aimed at enhancing the proposed solution at other levels too.
In addition to the technical aspects, the Life AgriSed project was assessed economically with the drafting of a business plan and environmentally by performing an environmental life cycle assessment analysis to assess the environmental sustainability of the technologies used. Our technologies and the results obtained were disseminated through workshops, seminars, scientific and promotional articles, both in Italy and abroad.
The response and participation of the public were truly remarkable, confirming that environmental issues are a very hot topic, both socially and commercially.
Our main activity is growing small, medium and large plants. We work with national and European markets. We decided to take part in the AgriSed project because we believe that environmental topics are of key importance in our sector. The aim is to find environmentally sustainable solutions in order to reduce the environmental impact as much as possible. In our case, the use of peat. These sustainable alternatives, however, must also have a professionally optimum cost-performance ratio. I must say that the results obtained from the growing media tests of the Life AgriSed project live up to this expectation. We have presented the project on several occasions, for example at the International Trade Fair for Plants in Essen, where we take part as exhibitors, and to all the customers who have visited our nurseries for their seasonal purchases. Our customers have shown great interest and attention to the topic, and have even asked us if they could specifically buy the plants grown and tested with the growing media of the Life AgriSed project.
Lastly, in order to maximize the impact of the project, the consortium developed and implemented an extensive dissemination and communication campaign. A project website and social media pages were created, and dissemination material such as brochures, roll-ups, banners, posters, and Life AgriSed gadgets were produced and distributed. The beneficiaries also took part in some of the leading events in the sector, taking part in national and international conferences and attending the most important European and world trade fairs. Specific actions were implemented to reach out to authorities, policymakers, and representatives of associations and non-governative organizations working in the fields of waste, soil, agriculture, and environmental sustainability.